Conjunction, junction, what's my function? And not an or will get you pretty far. Actually, it's and but an or in the song. If you don't know it, go check it out. Schoolhouse Rocks. It's awesome. Okay, and, not, and, or. These are meant to be used logically as opposed to grammatically, and there's a little bit of a difference. If we're using an and we're talking about events, this means that both events must occur. For this to be true. Not means the event following cannot occur. That would mean success. Or everything other than that event occurring would be success. And then finally the or, this is very important that you understand this. This is not a grammatical or. When we say, would you like tea or coffee, the expectation is you are only going to get tea or coffee. You're not going to get both. But in logic or in computer science, when you say or, if you ask for tea or coffee, if you get tea, that's success. If you get coffee, that's success. If you get both tea and coffee, that is also success. So this is not an exclusive or the way it is in English, which typically implies you're only going to get one of them. A logical or implies that if I get one or the other or both, then that works. So an or here means either event occurs, and then I'm just going to say or both. So we're not excluding the possibility that both events could occur. Okay, then there's a interesting little scenario down here where we're going to pick a random bill out of a bag. I know which one I want to get. But first we're going to define some events. And our events are selecting one that's got a odd number value on it. And so we're going to list out what are those denominations, like 1, 2, 5, 150, whatever it happens to be. Event B, randomly selecting a bill with a building on the reverse. And event C, randomly selecting a bill that does not have a president on it. There will probably be some debate about some of these, and I will ultimately decide what the way to do it because it makes it a more interesting assignment. All right, I'm going to pause it for a second, and we'll come back and talk about these. All right, welcome back. Event A, odd number. The only two with odd numbers are 1 and 5. You could argue 50, oh, it's a 5, but it's 50. It divides by 2 and doesn't have a remainder. So 1 and 5 are the only two that are odd. B. Now this one, some people might think the pyramid here is a building, but it's not. I mean, it could be, but we're going to make it not to make this more interesting. And so we're going to say that the pyramid is not a building. It's kind of a fictitious building anyway. It's only got 13 levels. It's supposed to represent the Union. So we're going to say that doesn't have a building on it, doesn't have a number on it, and the 2. Obviously, this is where they're signing the Declaration of Independence. So everything else is a building on it. So everything else, the 5, the 10, the 20, the 50, and the 100 all have buildings on them. Okay, and that's supposed to be a 10. All right, and then finally C, ones without presidents. And the ones without presidents, there are 2 here. There's Benjamin Franklin, and then Alexander Hamilton was not a president. I actually had to look that up. He was just Secretary of the Treasury. So our 2 without a president are Hamilton and Benjamin. All right. So then we can go ahead and populate a more complicated Venn diagram down here. And we might want to label these. We don't have to, but this is our event A is basically, this is odd. This is building. I'm just going to write BLDG. Oh, you can't see that. And finally, the last one is not Prez. That's what's in this one. Oh, and notice which bill did we not use? Right? That's the 2. So the 2 is going to go outside the box. So we're actually going to list the numbers. We're not going to say how many of them there are. We're going to actually list the numbers. So this is not 2 events. This is actually a $2 bill. Okay. So go ahead and fill those in with the actual things that go and where things overlap. Put the actual listings in there. I'll pause it. Okay. 1 is odd. The question is, does it have a building on it or does it have not a president on it? It does have a president on it, so it's not going to be in this area. And we decided it does not have a building on it, so it goes up here, whereas the 5 does have a building on it, and so we're going to put it in this space right here. And so once again, we are listing actual denominations as opposed to usually, oftentimes, we list numbers in there. Let's do event C next because I think it'll make it easier. So event C, we're looking at not presidents, both 110, and the question is, are either one of those odd, which neither one of them are, or do either one of those have a building on it? And actually, both of them have a building on it. So both the 10 and the 100 have a building on the back. Let me just double check. I'm not screwing things up. Yeah, that's right. So the 10 and the 100 both have a building on it. And then it kind of everything that's left over goes in the other one. So we've taken care of the 5, 10, and the 100. So there's also a $20 bill that'll go over here and a $50 bill. Okay? All right. So that's our setup. I'm probably going to be jumping back and forth. Flipping the page over. Probability of each one of these things. Probability of A happening, because this is where we're going to count them up. We have, once again, we have 1, 2, 3, 4, 5, 6, 7 events. And the probability of A is there are 2 things in A. So the probability of A is 2 out of 7. And the probability of B, go back over here, probability of B is 1, 2, 3, 4, 5 out of 7. I think you can see that. And then probability of C is 2 out of 7. All right. Probability of not A. Now, I don't have to flip it back over now because these are complements. So probability of not A is 5 out of 7. Probability of not B is 2 out of 7. And probability of not C is 5 out of 7. Identify the outcomes of the intersection events and then calculate the probability. So we're going to do both. So A intersection B. If I flip it back over, A intersection B, there is just the $5 bill in there. That is the only thing that's in that intersection. So the event, the outcome for success is 5. And so my probability of A intersection B is just 1 out of 7. Okay. B intersection C. B intersection C, there's both the 10 and the 100. So that's going to be 2 out of 7. So the 10 and the 100. And so the probability of B intersection C, which you can also say B and C, is 2 out of 7. And the probability of A intersection C, there's nothing in there because there is nothing that is both odd and also doesn't have a president on it. So probability of that happening, this is null, or you can sometimes people will put like a 0 with a line through it, which means the empty set. Or sometimes people will put empty brackets to mean the empty set. Or sometimes people just leave it blank. But so the probability of A intersection C is 0 out of 7, or even just 0. All right. So A or B. So we can look at this. A or B means it can be an A, or it can be in B, or it can be in the intersection. And it's definitely not the same as A and B. A and B is the intersection. This is circle A or circle B, or the area in between is also okay. So we're not going to exclude that area. This is very important because grammatically sometimes we might think we might. So it means A or B, which is both circles including the intersection or the overlap. All right, I'm going to try to wrap this up pretty quickly. Outcomes for A. Once again, we've already said the outcomes for A are 1 and 5. Okay? And our probability is 2 out of 7. So there's outcomes for B. We decided were 5, 10, 20, 50, and 100. And so there are 5 out of 7 there. Intersection A and B. Once again, we said that was, got to jump back over. Intersection A and B was just a 5. That was just the 5. And so that's 1 out of 7. And A or B means anything in both. So if I flip back over, I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I've got 6 items. Okay, so that's 1, 5, 10, 20, 50, and 100. And it's 6 out of 7. And this asks the question down here. If A and B